This video is for section 1.6, Solving Linear Inequalities. So we've been talking about equations. This first sentence, you can fill in the blanks here. An equation is a mathematical sentence with an equal sign as the verb. Today we are going to expand that and start talking about inequalities. So an inequality is also a mathematical sentence, but instead of an equal sign, it's going to have a less than sign, which looks like this, a greater than sign, which looks like that. Let me erase that little dot that got there, or a less than or equal to sign, or a greater than or equal to sign. So there's 4 different types of inequalities, and just to make sure that you know which ones these are, this first one is less than, second one is greater than, and then these last 2 correspond to that, but they also have or equal to. Just like before, the definition of solve hasn't changed, except now you might have more than one solution. So solve means to find the solutions or the values that make the sentence true. So when we were talking about equations, we would find a solution that was something like x equals 3 or x equals -5. Now with an inequality, you might have more than one number that makes it true. If you have more than one number, instead of having a single solution, you have a solution set. And let me just give you a quick example of this. For example, using the less than sign, if we are told that, or if our solution is that x is less than 3, you can probably think of lots of numbers that you could put into that sentence in place of the x. For example, 2 is less than 3. 0 is less than 3. -18 is less than 3. In fact, there's a lot of numbers, including some fractions and some decimals. For example, 1/2 is less than 3. So this is an example of an inequality that has more than one equation or more than one solution. And we like to write those in something that we call set notation. So for the solution x is less than 3, that would be all of the numbers, and I'm going to first draw it on a number line, starting with 3, but not including the 3, right? 3 is not less than 3, but it's all of these numbers that are on the left side of the number line. So something that you're going to find that we're going to do a lot in this section is graph our answers on a number line. So in this example, we are not including the 3, so I'm using an open circle to indicate it's not the 3 itself, but then this arrow that I'm filling in shows that it's all of these numbers to the left of 3. Another way that we can represent that answer, other than graphing it or writing it as an inequality, is interval notation. So notice that we have an interval here. We have a section of the graph that makes it true. It's everything from there to here. Now, how would we indicate that? We would say that our answer is all of the numbers between -infinity, because this is just going to keep going. We can't find a number that's too small to be less than 3. So it starts at -infinity, and it goes all the way up to 3. And anytime we have an interval that starts with infinity or -infinity, we always use a round bracket on that side. And then on the side that has a number, like this one goes from -infinity up to 3, since we are not including the 3, we use a round bracket there as well. So off to the side here in the margin, I'd like to just spend just a little bit more time before we move on talking about interval notation. So we just said that x is less than 3 we show as -infinity to 3, and there's round brackets on both the -infinity side and the 3 side. If we are talking about all of the numbers bigger than 3, we would say x is greater than 3, and the interval notation for that is 3, infinity with round brackets on both sides. Now, 2 other cases that we might have we might have that x is less than or equal to 3. So you might guess that that's going to be similar to what we have up here with x is less than 3, and you are correct. We would write negative infinity to 3, and we'd use a round bracket on the negative infinity side, but since we are including the 3, we want to use a square bracket. Okay, and that's just indicates that it's not just the numbers less than 3, but it's also 3 itself. And if we were graphing this on a number line, instead of putting an open circle at the 3, we would fill in the circle and then have everything to the left filled in. So that indicates it's 3 plus all of the numbers that are less than 3. And one last one that I just added here, x is greater than or equal to 3. And notice that these always go in order. We always start with the smaller. This is 3 going up, so I list 3 going out to infinity. And then again, I use a square bracket to indicate that it is or equal to. And then the infinity side always has a round bracket. Okay, hopefully that will help you as we get more in depth into interval notation. Let me scroll up a little bit. Okay, when we are solving inequalities, so we're going to start with some inequalities. Just like equations, we solve them to find out what the values of x are. We're going to do the same thing with inequalities. And we have an addition and subtraction principle. We have multiplication principle. Basically, you can add something to both sides of an inequality and it's still true. You can multiply both sides of an inequality by a positive number. Notice C here is positive. So if we multiply both sides by 2, the inequality is still true. If we multiply both sides by 19, the inequality is still true. But look at this last one. If we multiply by a negative number, what happens? The inequality turns around. Notice this started out as A is less than B, but when we multiply by a negative number, for example, -2, if we multiply both sides by -2, it is now greater than instead of less than. Do you see the difference there? This is something that only happens with inequalities, and you need to remember this. If you multiply or divide by a negative number, you have to flip the sign around. And this is true for less than. It's also true for greater than, less than or equal to, or greater than or equal to. So let's do an example. Here I have an inequality. 4 minus 2x is less than 2x plus 16. We want to solve that for x, and you do the steps just like you solve an equation, with that one exception of when you have to turn the sign around. So I want to get all of the x's onto the same side. So the first thing I'm going to do is I'm going to subtract this 2x over. So on the right side, the positive 2x and the negative 2x cancel out, and I end up with 4 minus 4x is less than 16. Notice that I still have that same sign. You keep that sign the same unless you multiply or divide by a negative number. Now I need to subtract 4 from both sides. So I'm doing the same steps I would do as I would if this was an equation. I get negative 4x is less than 12. And now to solve this, I need to divide by a -4. -4 divided by -4 is x. On the right-hand side, I have 12 divided by -4 is -3. But because I divided by a negative number, I have to flip that sign around. It was a less than, and now it becomes a greater than sign. Okay, so our solution to this is x is greater than -3. A couple things you might be asked to do, and we're asked to do here, is to put it on a number line and to write it in set notation. So just realize this is 3 different ways to say the same thing. x is greater than negative 3. If you're just asked to solve it, that might be the way you write your answer. If you are asked to put it on a number line, you're going to draw your number line. And in my math lab, they will probably have your number line drawn for you, and you will just be filling in the appropriate spots. So here's our number line. I've labeled negative 3. Since it is greater than and not, there's no or equal to here, right? I make an open circle. So make sure that it is open. It's not filled in. I would fill it in if it said or equal to. And which direction do I fill in? To the right or to the left? Which of the numbers would be greater than negative 3? As we go to the right, negative 2, negative 1, 0, 1, 2, these are the numbers that are greater than negative 3. So that's the direction that I fill in. And I always just make sure that's definitely darker than the regular. Of course, in my math lab, I think maybe it turns blue or red or something. So it's going to be pretty easy to tell. If you're doing it on paper, just make sure that I can definitely tell that you're filling in that right side. And I usually fill the arrow in as well. Interval notation. We are starting with negative 3 and we're going out to the right. So this is going toward positive infinity. And infinity, I'm not sure why that just messed up. Okay, so we have positive infinity. On the infinity side, we always use round brackets every single time, whether it's positive or negative infinity. But on the numerical side, this negative 3, we need to decide if we use a round bracket or a square one. Since it doesn't include the negative 3, we use a round bracket.